Welcome everyone. Welcome in lecture number 3 of the subject highway and traffic engineering. Today the lecture contained a lot of conceptual terminology such as what is the philosophy of pavement. We will also cover the what is the main difference between fatigue and rut, and also we will talk about the contract pressure. We will also talk about the layered system as well. What is the difference between modulus and resilient modulus. We will also try to talk about the what are the different aspects of design such as functional and structure, and we will also talk about the continuous loading when we have a lot of continuous loading and what will be its relative damaging factor as well. So the first topic of today is about what is the philosophy of pavement. As you can see here, the first phrase when we just say that pavement is alive. What does it mean? That how pavement could be alive? Okay, pavement alive means that pavement can contract and expand when we have because of the thermal expansion giant. Most effective way to control thermal crack, we usually provide there a giant. So when the temperature rises, it expand. When temperature falls, it contract. So the same contraction and expansion happen due to the change or cement hydration, which we call the exothermal process. Okay, so pavement could move from contraction to the expansion, and so far according to the theoretical or according to the field observation, the maximum of around 30 mm expansion has been recorded. The second one is about is the pavement is subjected to moving traffic, which should be repeated in nature. So that means that it should also counteract the moving traffic load as well. And of course, every repetition of the traffic, it actually like damage the pavement structurally. Okay, so we have the two aspect. One is the structural aspect, while another one is the functional aspect. While both of them have a lot of differences, such as when we talk about the structural aspect. Structural means the pavement ability to sustain the load, and how well it actually protect the subgrade. So the pavement are basically designed for like a time, so that it should be serviceable within the same period, and with little bit maintenance as well. Okay, so in other words, we say that pavement is basically designed to fail. So each and every pavement have a certain design life. As I mentioned in the previous lecture, that whenever someone asks you about the pavement life, you should just come up with the not with straight away answer like such as 20 or 30 years. So you just mention that if there is a rules and regulation regarding loading, terminology, and so on, and so then it will fulfill its design life. Otherwise, its life will be shortened. The second important topic of today is we will also try to understand what is rutting, what is fatigue. So from the top, you can see when we have a a wheel is acting basically from the top. So basically, what is rut? The longitudinal depression in the wheel path is called rut. The longitudinal depression in the wheel path is called rut, while the permanent deformation of a pavement due to progressive accumulation of a viscoelastic vertical compressive strain under the traffic loading. So what is basically crack? As you can see here, we have also we have a fatigue crack, but first of all we will try to explain the crack as well. So the crack is basically the separation of a continuous medium. So later on, first of all, we have the depression in the exactly in the wheel path, and after that it convert to the fatigue crack. So what is fatigue crack? Fatigue crack is basically due to the repetitive load, due to the series of interconnecting cracks, which actually lead it in the fatigue form. Okay, here we have also just mention something about viscoelastic material as well. So we call the bitumen is a viscoelastic material. Okay, what is visco, what is elastic? Actually viscous means resist, the ability of a material which basically resists water and also resist shear flow and strain linearly with the time when the stresses are applied. What is elastic? Which contain, actually the bitumen naturally contains visco and elastic characteristic under the action of the loading. So the elastic is basically when we have under the application of a load, when the whole material is stretched and immediately it return to its original state, or this when the stress is basically removed. So the viscoelastic, basically bitumen, we called it a time dependent strain material. Okay, so rut is basically the crack in the longitudinal path of the wheel, while the fatigue is basically due to the repeated load and because of the interseries of the cracks, okay, in the stabilized layer. The next topic is about the typical strain in the three layered system. So we will talk about the three layer system. So this is at a design level. Okay, the first one is bitumen bound material, second one is granular base material, while the last one is a subgrade material. First one is what is basically elastic modulus. So you need to understand some of the concept as well. Okay, if someone is interested in the design lecture, so you can also follow me for the design lecture as well. Okay, but to go in a very in a very deep, first of all we will try to explain the basic parameters as well. Here you can see the first difference. You need to understand what is modulus and what is elastic modulus and what is resilient modulus. When we talk about modulus, modulus is basically the derivation of a stress divided by strain when we have the slow loading parameter. But when we talk about resilient modulus, then of course the formula is same, stresses over strain, but we will refer it to the repetitive loading, something which is completely repetitive with passage of time. But when we talk about the resilient modulus, so basically resilient modulus is the property of a material to identify and characterized unbound pavement material. So we have two type of a pavement usually. One is bounded, another one is unbounded. Unbounded means when each and every layer in the bitumen, when they behave individually, while the bound one, when all the layer actually behave as a one unit. Okay, so the elastic modulus is basically the quantity that measure an object resistance to being deformed elastically. So means we are referring towards the non-permanent changes or non-permanent deformation. When we talk about the Poisson ratio, here we will consider the example of a rubber. Okay, so when we stretch a rubber in the longitudinal direction, so the negative ratio between lateral strain and longitudinal strain is basically the ratio of a Poisson ratio. Okay, while the thickness, where we have the value of h1, so basically it is we call the height of each and every layer. So the same three parameter will be used in all of these three layers. Okay, while in the typical three layered strain system, okay, so all of those material, the material at the top will always have a higher Young modulus. Young modulus is basically the material property. E1 is basically the elastic modulus, or we call it Young modulus as well. This is basically the material which is basically based on the material property. Similarly in E1, E2 and as well as in the E3, okay, in the subgrade layer as well. This is very much important. So if now on you understand properly, that will actually resolve a lot of problem. So what is contact pressure? Contact pressure, or when the stresses are developed due to the wheel load or the tire imprint area of the pavement surface. Okay, so we have usually pressure on the contact between the vehicle tire and road pavement, which is very important to determine in terms of the load intensity. A uniform circular vertical contact stress is commonly assumed as a contact pressure, where we have contact pressure is equal to load divided by area, which we call F by A. Okay, so we usually measure is a tire or in term of the inflation. Basically, as you can see here, contact pressure based on pressure and stiffness of the tire wall. It is the extent to which an object resists. Okay, so when we talk about the stiffness are basically the permanent deformation. So the next phrase is about when we have a low pressure tire, we have the contact pressure is greater. What does it mean? Basically, the contact pressure is uneven in the contact path and lower than air pressure for the radial tire. We have usually two type of a tire. One is called bias tire, while another one is called radial tire. As you can see here, whenever we have the inflated, means when we have the gauge of a tire is little bit higher. So as you can see here, so the from the mark the contact pressure as well as the area through which the load is basically transferred from the vehicle to the pavement surface. Okay, so it's exactly adding, and at the same time the tire actually act as a point, or we can call it at the edge of a tire load is basically transferring. But if you look here to the area where we have the inflated, it means when the whole tire is kind of in a proper contact with the road across the entire tread width. Okay, and we will also consider the another condition when we have the inflated road as well, means where we have little bit the air gauge is not according to the standard. So means usually we measure the load in terms of a 30 psi. So in that specific case, you consider that we have a load of a like 22 or 25, means which is almost 1/3% is lower. So in that portion at the edge of a tire, so the load is transferring, but the middle portion of the tire is even not in a contact with the pavement surface. So what is going on here? Okay, you need to understand the phenomena of the tire through which basically it exert pressure to the pavement surface. There are a kind of a small type of a wire which are installed in the tire assembly, okay, which actually work as a reinforcement. So if we have that specific case, so all the pressure is actually exerting on those edges. So the middle portion, which is actually designed to transfer the load, so we have the whole load is basically transferring at the edges. So there will be a huge type of a corrosion at both end of the tire. So what will happen? The lifetime of the tire will be reduced. Similarly, as you can see here on the top, the area which is basically at the loading cycle, for example, you just need to imagine that the tire is moving. Okay, so one is the loading edge while another one is the trailing edge. The loading edge is basically the edge which is in a direct contact with the road, while the trailing edge is basically the edge which is basically taking the rotation. Okay, I hope it's clear now. We have two basic aspects, okay, of the design to design the pavement. The one is the functional one, another one is the structural one. Functional means which indicate that how well pavement is serving the road user at any particular time, while when we talk about the structural design, it is the ability of the pavement to measure that how much it is sustain the loading and how well it protect the subgrade. So the functional is basically refers to the safety and riding quality, while the structural design or aspect is actually related to the to the accumulation or the suspension of the traffic loading. Actually, when we what we expect from the pavement, that it should fulfill the functional as well as the structural aspects of the design. Okay, so now we have another example. So how we usually see that is the pavement is according to the structural performance or not. So we usually measure it with the strength. So how we define strength? Ability of a pavement to sustain the load and how will it protect the subgrade. When we talk about the functional performance, we usually see that the pavement should provide less skid resistance. It should also reduce less wear and tear. There should be less friction, and it should be within the limit as well. The number of rutting pops out and pavement unevenness, it should also be in a control. So those are all the parameters through which we actually measure the functional performance. When we talk about the comfort, so comfort is basically the level which is directly related to the smooth travel quality, and also the ditches, as well as the from the comfort we means the safer and comfort ride, where we have the less chances of accident because of the road condition, which is basically measure from the RI, which is roughness index, or pavement condition index, RIRI, which is international roughness index as well. So these are basically the three different structural and functional performance through which we actually design or like measure the whole pavement as well. Okay. Pavement serviceability index is very much important to evaluate the functional and structural condition of the pavement. So the functional is basically related to tell us that how well road is actually serving and under different condition. When we talk about the structural, when we refers mainly toward the loading criteria, so we relate the term to the track rutting, cracking and unevenness. Okay, we have those are basically the different type of a elements such as terminal serviceability, regional factor, structural number, soil support, reliability, resilient modulus, and so on, through which we actually determine the current as well as the future and as well as the condition when the pavement were actually built. As you can see here from this figure, from this chart, this is for different type of a expert. For example, if we send a group of a 10 pavement expert to the group to like give them a task that please tell us the pavement serviceability index, so each and every one will have a different criteria, but the maximum level is 5 while the lower level is 0. But when it's below than 2.5, it means that the crack is start deteriorating. But if it's above than 2.5, it's still usable with maintenance. Okay, and but this 5 value in the flexible pavement is quite theoretical value. So from the practical experience, it is measured that we can only reach to 4.5. According to that figure, so now what we should do when we design the pavement, so the vice planner, he should consider actually all those parameters such as climate condition, what type of climate variation do we have, and what type of a load magnitude you like need to keep in mind. Is I already mentioned this thing that when the pavement developer, they usually design, they consider the input parameter. So basically the climate changes, environmental variation, load magnitude variation, volume, density and material property and rigidity of the material, those all are actually the input parameter, which is a designer, is a pavement expert, you actually need to keep them in mind and also give it like a lot of priorities while designing the pavement. This is very much important. Okay, so this specific word is basically refers to so many things. Okay, so on the basis of all those steps, we actually select the functional and structural performance. Okay, so the life after which the rehabilitation or maintenance is needed, or below which the desirable standard need to be improved. So all those are basically very much important, which we derive it from the IRI, International Roughness Index, RI Roughness Index, or Pavement Condition Index. Okay, so this was the condition when the pavement were originally built. Okay, so but with passage of time and under the action of a traffic loading, its performance, its ride quality almost reached to zero. Okay, so at that point we actually need rehabilitation. Rehabilitation means to elevate its riding quality. So for that purpose we come up with patching or maintenance technique. Okay, so we increase the riding quality, okay, so and reach it to at some level. So the rehabilitation means patching or the maintenance of the surface. Maybe some of you have idea, we have four almost different type of a maintenance. In the type 1 we like remove the like we only do the like fill the pop out and also fill the small cracks. Okay, in type 2 we remove the wearing course, while in type 3 we remove the wearing course with the base course, while in type 4, type D, we actually remove the whole pavement, or sometime we come up with another alignment as well. Okay, the similar thing is actually the similar technology is also like the parameter is going on with the structural performance as well. To improve the structural performance, so before, to increase the structural capacity after the traffic aging, we would like to improve the rehabilitation. So we come up with type 1, 2, 3, 4, any type of a maintenance quality. So the rehabilitation level is improved, but after some time, as you can see here in like both figures, so this is a kind of a buffer or common line, or after which the pavement condition is almost reached to zero. So after that its service is not possible. Okay, we have different type of a traffic load characterization. Okay, which is like changes with passage of time from places to places. Okay, so the when we design the pavement, we need to consider all type of a pavement, starting all type of a wheel loading, starting from the car, pickup, buses and trucks and trailer and so on. Okay, this graph is really much important. Okay, so it is basically the relation of a repetitive load with the failure. The more number of application of a load will actually reach it to the yielding limit quickly. So when we have the more repetition of a loading, it will reach to the deterioration of the failure. We have another parameter which we called the pressure level with the sinkage level of the material. So basically we measure the material sinkage relation with the pressure level as well. Okay, so if we talk about the load cycle, so load cycle is defined as the duration from one peak time to the next peak. So in general, all cycles do not have the same amplitude. Every load cycle have actually different type of a magnitude of the loading. So here is another term, what is repetition. So repetition or repetitive application of a load which is actually related to low magnitude, and also application of a single force or sufficient magnitude to cause injury. As we already learned that every movement of a wheel is actually damaging the pavement and somehow up to some extent. So how much it will actually damage the whole pavement, this thing is actually dependent on what? Dependent on the magnitude of the loading. Okay. Now we are trying to understand what is ESAL. ESAL is actually equivalent standard axle load. In a very simple word, the ESL is the standard axle repetition through which we determine the standardized wheel in a correlation for a different wheel configuration using the material damage, as well as to also assign the thickness of the pavement as well. Okay. So the equivalent axle load factor is a factor ratio between the damage caused of the passage of a individual axle of a pavement as well as of a standard axle of the same pavement as well. Okay. uh, in our condition, 8.2 ton per axle is actually considered as the ESL or the standard axle. Okay. We can also determine its load equivalency factor as well. So basically how much ton of existing load is going on the pavement, and if we divide that with our ESL, so we can get our load equivalency factor. In a short word, if the load is if the pavement is actually designed for 8.2 or 8 ton per axle, and if the moving load is 11 ton, so what we can do, we can divide 11 divided by 8.2 of a power of a 4. So you can get that how much at what factor it will actually damaging our pavement, because we are moving above the design parameter. This is very much important. This is a relation factor between different type of a axle loading and relative damage. As you can see here, at one end we have the damage per passes, while at another side we have the single axle load in tons. Okay. So if we have like the standard axle for which our load is actually our pavement is actually built, so if it's 8, so it will damage per pass will be the factor of 1. So the more it will grow on, so like for example at 9 the factor will be 1.4 1.1, while at 10 it reached to almost 2.3, at 12 it reached to 4.7, at 24 it is 75. So keep in mind, in a simple word, if we have a axle load per ton of a 24, so after the repetition of his like it actually damage our pavement for almost 75%. So basically the damage per passes are actually, when it reach to like 70 or 80 damages per passes, so it is deteriorate or like reach the pavement, the design life of the pavement very quickly. So keep in mind, the more higher axle loading in tons, and so if you will increase it damage per passes, so that will actually deteriorate the pavement early for as compared to the its design life. As well as you need to understand one thing, if you talk about the context of Pakistan, under the NATO supply in 1999 and 2000, when the Karachi shipment was started, so they transported the container from Karachi to Afghanistan through Peshawar. Okay, so I was working with one of the project funded by United Nations. Okay, so through the Congress money, they were actually building a road from Peshawar to the Turham past Turham border. Okay, excuse me. So the pavement were actually designed for 9 ton per axle, but when we measure through the FWD, the flexometer, following weight deflectometer analysis with the help of a geophones and sensor, so the existing load were actually moving almost 22 to 26 ton per axle. So you could imagine that how much it will actually damage our pavement. So in such situation, as we mentioned that about the input parameter, that we should consider all those input parameter as well as the load magnitude as well.